Question 2. Consider functions f and g. F equals x squared plus 5x plus 6. G equals x plus 3. Match each expression to the correct combined function. So first off, we're just adding the two functions. So we're going to take x squared plus 5x plus 6, and we're going to add to it x plus 3. You don't really need the parentheses when you're adding, but it's a good habit to get into. Here we're just adding like terms. So I'll notice x squared does not have a like term. So I'm just going to bring x squared down. 5x and x have a like term. We combine those and that gives us 6x. And then 6 and positive 3 are like terms. That gives us positive 9. So x squared plus 6x plus 9. Yeah, and that is an answer choice. All right, second question. Now we are subtracting the two functions. Now this one, you do need that negative symbol or you're likely to make a mistake. So we're going to take the f function, particularly the second function we need in parentheses. So what this tells us is we've got a -1, essentially, that we're distributing. We're taking the opposite of positive x and positive 3. So what we can do is we can drop the parentheses if we remember to distribute that negative symbol and make the x plus 3 the exact opposite of what it was. So now it's -x minus 3. And then just like the last one, now we want to get like terms. X squared still has no like terms. 5x and -1x. Combine those and that gives us positive 4x. Positive 6 minus 3 gives us positive 3. So the answer is x squared plus 4x plus 3. Yep, and there it is right there. Next one is multiplication. I always encourage a box model, or in this case maybe a rectangle model. Help us keep everything organized. Like my box, it's going to be a 2x3 box because one of the factors we're multiplying together is x squared plus 5x plus 6. Really all we're doing is we're multiplying everything in f times everything in g. The box just helps keep everything organized to remember that we do every single type of multiplication. So first, x squared times x, that's x to the third. Then we do x squared times 3, that gives us positive 3x squared. Next, we've got 5x times x, that's positive 5x squared. Then we've got positive 5x times positive 3, positive 15x. Finally, 6 times x, positive 6x. Positive 6 times positive 3 is positive 18. The great thing about the box model too is now at this point our like terms, not always, but typically when we do this, they're going to be diagonal from each other. So those two we can add together, and these two we can add together. And then x to the third does not have a like term, neither does positive 18. So they both come down. The x squared, 3x squared plus 5x squared is 8x squared. 15x plus 6x is 21x. Finally, we're going to tackle the division problem. So that's f divided by g. So that's going to be x squared plus 5x plus 6 divided by x plus 3. You could use synthetic division, you could use long division, but if you remember your factoring rules, factoring would be the easiest way. We're going to take this numerator, the f function, and factor it. So our two factors, the first two spots have to be x and x. We're just doing reverse multiplication. That's all factoring is. So those first two spots have to be x because x times x gives us x squared. The last two numbers, we got all positive signs here, so we know these last two numbers are both positive. The last two numbers have to multiply together to give us 6 and add together to give us 5. And a big hint of what those two numbers are going to be, one of them probably going to be 3. And yeah, 3 times 2 is 6. 3 plus 2 is 5. So that's how you factor the numerator. And now this is really easy to divide f by g because the x plus 3's just cancel each other out. And what's left over is x plus